The Higgs boson. You may have heard of it, but what is it? And what would the world be like if there were no Higgs boson? Well, then there'd be no world. Its particles wouldn't be able to stick together, and they'd just float around aimlessly forever. And where would that leave you? Nowhere. That's where. You wouldn't exist. But let's step back for a minute. Or rather, let's step inward. All objects in the world consist of matter, and all matter is made up of atoms. Remember that atoms themselves are made up of protons, neutrons, and electrons, and those particles are made of even smaller subatomic particles, such as quarks. Scientists have created the standard model of particle physics to describe these subatomic particles and how they interact with each other. The standard model is able to be applied to many things, including electricity, magnetism, and radioactivity. But the standard model had a hole in it. Scientists were unable to fully explain how these subatomic particles gained mass. This is where the Higgs field comes in. It is a field of energy that exists throughout all of space, and it is composed of Higgs bosons, which are elementary particles. All subatomic particles pass through and interact with the Higgs field. Some of these particles, like photons, whiz through and barely interact with it, resulting in very small mass. Other particles, like quarks, drag through and interact with the field a lot, which results in a larger mass. With this, the Higgs boson is able to successfully fill in the hole in the standard model. Now, you might be wondering how in the world scientists were able to discover such a thing. In 1964, a group of scientists, including Peter Higgs, proposed the idea of a mechanism that would suggest the existence of the Higgs particle. This idea helped encourage the eventual design and creation of the world-famous Large Hadron Collider, or LHC. The LHC is an enormous ring-shaped machine located in Geneva, Switzerland. It sends beams of charged particles whirling around in opposite directions through the ring, constantly whacking them to make them fly faster and faster until finally, wham! They collide, leaving tracks of subatomic particles that scientists can study. Collisions expose many types of subatomic particles, and on rare occasions, a Higgs boson can be seen. This event finally occurred on July 4, 2012, and researchers were finally able to put the elusive puzzle piece into place. So what are we supposed to do with this information? What can the Higgs boson do for us? And what kinds of things will it bring in the future? Some scientists speculate that this discovery will help them gain insight into dark matter, which they think accounts for 23% of the universe. Other scientists say that the discovery will allow us to produce new particles that could have practical uses. No matter what new discoveries this knowledge will bring us in the future, we know we can thank the Higgs field for allowing us to exist in this world. Thanks, Higgs boson!